now that we have the community website, we're going to have to try to piece together some sort of database or list that we can maintain, maybe a wiki or something, so that we can know what's out there. Obviously, trying to document things like this on a presentation, it's not very friendly to updates. So just a quick overview so I can try to keep us from getting too far off schedule here. So we have the very first thing we probably worked on was the VxWorks 6.x, which, at Goddard, unfortunately, we're so constrained by the people that we have available to work on this, myself included, that we tend to just support the neediest projects and then try to keep up with the latest versions of the OSs and the latest technologies to incorporate in our CFS software. So it tends to be project driven, and when a project uses a new platform, that's when we tend to update it. But luckily, now that it's getting out there in the community, people are starting to provide support for, say, newer versions of VxWorks and much improved support for Linux. Like, Joe Hickey was on the phone earlier. He's made a lot of improvements, and he has a lot of improvements in the pipeline for the POSIX-like systems. So we have our basic standard POSIX Linux OSAL port. We have the VxWorks non-SMP, non-memory protected port. We have a basic RTEMS port that we used for our MMS mission. I'll talk more about the updates to that. And some of the stuff that's in work, the CubeSat that I'm working on is using FreeRTOS, so I did a FreeRTOS OSAL port. But if you want to know more about that, you can just chat with me after this or over the next couple of days, because there's some extra work that has to be done for FreeRTOS, because VxWorks and RTEMS and Linux, they have the whole infrastructure that you need. They have the C libraries, the dynamic loaders, they have file systems and things like that. But with the FreeRTOS system, you pretty much have to start from scratch, unless, of course, it's provided for you. In the case of our CubeSat board, they had provided the firmware with FreeRTOS integrated, and most of the stuff we needed was there, so it made it easy. But that makes a generic FreeRTOS port hard, because what does that mean? You need file systems, you need a loader, and things like that. So I'm thinking about that. I have kind of a background project of trying to create a FreeRTOS port in PSP, OSAL port in PSP that would run on QEMU, like on an ARM simulator, so that hopefully when it's done, everybody could just bring up the CFS on FreeRTOS. Also, another thing we worked on was the VxWorks 6.7 SMP, and that, we kind of developed it, tested it, and didn't do much else with it since then, but that's going to become very important to us later. We did give it to Johnson, and I know Steve's using it, and he's made some updates to it, and so I think we're planning on taking what he had and continuing. And then another technology effort I did was I ported it to this Pike OS partitioned operating system for a technology demo, where I had a bunch of different partitions, each running the CFS, talking to each other. And then as far as PSPs go, we have VxWorks, and our lab system used to be the old MCP 750 compact PCI board. That's where we did all of our CFS development on. Now, Susie, you might, I noticed there's also this VxWorks 6.9 SP0. Is that the new boards that we have in the lab?
No. No, that came from Lord.
Oh, okay, that's your port. Yeah. So that's, okay. And so I noticed that's in the latest open source release as well. And And then, of course, we have the standard POSIX Linux port, and that's probably the first PSP and OSAL that everybody will encounter because that's the easiest to get up and running. And then in the latest open source releases, we have RTEMS 4.10 with a 686 QEMU target. And then I have 4.10, actually this, I don't think this is in, oh yeah. So this is in the open source repository, RTEMS 4.10, that I used on a commercial cold fire board that was for early development for our MMS mission. But I'll talk more about the RTEMS support in a minute, because I'd like to update that as well for the latest. And then we had VxWorks 6.4 on GPM, which was a BAE RAD 750. And of course, the free RTOS CubeSat project I'm working on. And this is the PSP for the VxWorks SMP work we did. And of course, the Pike OS that I did, which was on a Leon 3 development board as well. And so a lot of these, I consider these in development because they haven't really gone through the whole release process. But I know that the SMP for both VxWorks and RTEMS, and most likely Linux as well, are going to be important to us in the near future. And you know, if we can squeeze the resources in, free RTOS, we would like to support that as well. Future platforms at Goddard. So Jonathan, don't you have the Xenimi platform in work? And I know that.
So we have a OSAL for that, which really just uses the POSIX.
Oh, okay, so you use the POSIX, and I think it's my next chart where I know Matt Benson said he has the Xenimi native port.
Yeah, there's two of them. We picked the POSIX since it works just as well, and it underneath it also interfaces the Xenimi stuff. But I think it's worth mentioning that Lori has work going on for Xenimi in a partitioned environment. So extensions to Xenimi for partitioning, you know, hard partitioning like A-Ring 653. So that's something that might be useful for the future.
Okay.
For even CubeSats. So anyway.
And then, so some of the work we want to do coming up at Goddard, we have this PACE mission and the PACE OCI instrument, so the PACE CNDH. And they'll be using VxWorks SMP on a Leon 3 dual core. And the same processor card has the dual core processor, and it has a Leon 3 FT and an FPGA. Now we also have this board called the SCEB, the Small Sat CubeSat Electronics board that we're developing. And that has the same RTG4 FPGA, and it has the Leon 3 FT processor on it. And we're planning on using RTEMS for that, probably 4.11. And our W1st mission that we're just starting, it's going to have a board that uses the Leon 4 quad-core processor. And I would imagine, I think it's going to have a number of other processors on it as well for instruments and things.
Are they going to give us money to develop the?
They are actually. They do have some tech development money from what I hear. I don't know. We need the people though. So we're hopefully going to use RTEMS 4.12 with the SMP work, and so that gives us a great need for updating the OSAL and CFS to use SMP for both VxWorks and RTEMS. And I would imagine a natural extension to that is Linux for test platforms and any other type of Linux-based platforms we want to use SMP on. Some of the other platforms outside of Goddard, APL has Solar Probe Plus, where they don't use the CFS, but they use CFE, and they're using on VxWorks with a Leon 3 FT. I know you guys have the A-Ring port, but I'm sure you have like 20 other ports over there.
Did we give you a list? Because we have.
I'm sure we have that,
It's
but
like we have it on a PowerPoint chart. One thing I did want to
Yeah, I think we have several. Steve is kind of our OSAL PSP guy, so he would have the current list. But one of the things I wanted to bring out is the integrity port, because that's a whole new OS.
Mm-hmm.
And so we do have that, and it's actually just been released on the software.nasa.gov website. So if anyone is an integrity fan with A-Rink, we have an OSAL for that.
Okay.
So
Yeah, I mean, and it would be really great to have, you know, to be able to catalog these things online and be able to try to manage them. And I guess part of that is the formal definition of the PSP API and the test suite and the documentation too. It's just been so hard with the limited resources to even address a lot of this stuff at Goddard. You know, and this is a woefully incomplete list, I'm sure. And you know, I did get some feedback from Matt Benson. They have the native Xenimi port, and they have a Linux port that he said can run faster than real time. They got rid of the POSIX message queues and did some other things that allowed them to run in a simulator faster than real time. And he has PSPs for the Xilinx Zinc running either Xenimi or the PETA Linux. And I just threw this in here at the last minute. This is my own Raspberry Pi Zero based board that I'm building. I'm going to kind of try to make it as small as possible, and it'll be running the CFE and CFS. So I plan on running either Linux or RTEMS on this, because RTEMS runs on the Pi, and you know, this is a little mag compass accelerometer, has a bunch of sensors on it, this IMU. And so we could run it on just about anything we want to. So one of the things we're going to need to do soon at Goddard is we want to update the RTEMS OSAL port. We want to provide 4.11 and 4.12 compatibility. We need to incorporate support for the dynamic loader. For MMS, we use this extra library we developed called the static loader, which has worked out really well for us. It kind of became the bridge between our old statically linked systems and the dynamically loaded and linked systems. We're able to kind of statically load applications in a fixed memory location and yet still load them separately from a file system. And the CFS and the OSAL is happy and it thinks it's dynamically loading the app, which it really is. It's dynamically loading it, but it's loading it to a fixed memory location. And it's very lightweight and very efficient. We're using it on our CubeSat. You know, for example, an average CFS app. It even supports compression on the file. Some of our apps are only on the order of, you know, 1.5 kilobytes on the disk. It's just really small. And it's fast too. But anyway, we would like to fully support the RTEMS dynamic loader. And
Are you expecting differences between 4.11 and 4.12, or is it mostly just things that changed up to 4.11?
yeah, I'm not expecting differences between 4.11 and 4.12, although aren't there some file system API differences?
Off the top of my head, I'm remembering that between 4.11 and 4.12, thanks to the guys behind me, so there was 4.11 has SMP that we call functional. 4.12, the SMP has just been beaten senseless, scaled up to at least 24 processors. It's got a lot of state-of-the-art scheduling, thanks to the ESA guys. But mostly we deleted things or flagged them as unsafe for SMP. So a few APIs went away. We're encouraging using thread local storage or what's the other feature? pthread keys.
Yeah.
But there might be a file system, but I don't think there is.
Yeah, actually, that's one of the things we have to change is we do rely on that RTEMS task key. So that was one of the APIs that went away. So we'll have to remove that, but that's not a big deal.
No.
And we also want to work on our RTEMS SMP port. You know, I have RTEMS 4.12 up and running on my Raspberry Pi 2, and the SMP works very well on that. I'm able to saturate all 4 cores, or 3 of them, and keep the other one open. The shell remains responsive, so it's pretty cool how that works. It's nice to have like a quad core test target for $35. And then of course we want to try to do the free RTOS port and make that official.
Just real quick, so I don't know why it needs to say GSFC up there. Couldn't somebody else that wants the VXWorks one or the art?
Well, no, I think this could apply to anybody, but I'm just saying,
Yeah.
just in my limited knowledge of the community, you know, I'm not aware of what other people's needs are or what they want to do. So I just wanted to make them aware of what we want to do in the near future.
Yeah, that as a roadmap, but if somebody needs it sooner, they can hopefully step up and
Well, of
actually
course,
do that
yeah.
work. Yeah, that's what I'm trying
Yeah, I
to
mean,
get at.
that's part of making people aware, so we can let them know what's important to us in the near term, and then, you know, we'd like to help with other things too, if we can, or get help with these things.
Yeah, because we're pretty much resource constrained,
Yeah.
especially since Alan ends up doing most of this stuff. And if somebody else wants to sign up, that'd be great.
Okay.
I guess to flip that around, I mean, so are there other needs? If anybody has anything they want to, you know, give a shout out to.
VXWorks protected memory mode, the RTPs.
We actually did another joint IRAD with APL a number of years ago. It was probably like 3 or 4 years ago. And originally our plan was to fully support the process model with CFS applications. In fact, you know, if you look at the way the CFS application is with the main thread, and you can create child tasks within the application. Originally, that was my goal, was to try to, you know, minimize global memory for the applications and have a main thread and be able to create child tasks almost like a POSIX process. And so we actually spent some time trying to port the CFS to that memory protected architecture. And it's going to require a lot of changes to do that. But, you know, I would love to see somebody take that work and continue, like being able to do the VXWorks like the memory protected process or POSIX process as well for a CFS app. Seems like they'd be a lot more portable for the, you know, the larger platforms that could support them. You know, it's like every once in a while I look around at the whole world of like Linux containers and the way they're packaging these microservices and things like that. And I think that would be really cool if a CFS app was kind of a standalone container. But so we didn't really complete that work. We decided that we were going to have to really touch a lot of the CFE core to make it work. But possibly some sort of a compatibility layer that provided the CFS or the CFE interface to a process-based CFS app, and then served as a bridge to the CFE core might work. What we did end up with was we were running instances of the whole CFE and CFS in one of those protected processes. And so we were able to demonstrate running multiple CFE systems on the VXWorks board with the memory protected process. So we kind of punted a little bit at the end and just developed that method of at least demonstrating that we could run the CFE in a protected container on VXWorks.
Yeah, that's very similar to the partitioning model, but without the time. So it's very similar to partitioning, and that's one of the ways we treated it. So when Alan, he actually had multiple CFE instances in different Linux processes, and he used SBN to talk between them, because SBN, treats it like a network and pulls it out. So you don't actually have shared memory between them. So I think you might want to get, and whoever really wants that is get involved in how it's architected. If you want true protection, it's going to be hard to go through every CFE, that uses, for efficiency reasons, uses a lot of shared memory, because the processors don't have the horsepower. So, it's a balance between performance and protection.
However, there was some projects that decided to go with protected memory during development.
Oh, yeah.
Because during development is where you get all those hammers, where you get those funny shared memory gotchas. And they actually may not have flown the shared memory, but they did use it when they were developing it so that they could detect the problems that they were having.
Yeah, just as an aside, if we're talking about scale of a system, the CubeSat that I'm working on, I think our current build, the code, including free RTOS, all the drivers, and all of our code, the code space is roughly around 1.3 megabytes in flash. And we only have 2 megabytes of RAM on this CubeSat, and we use all of it. I mean, we're just, there's no margins there. We just use everything we have. But we managed to squeeze much of the OSAL, CFE, and much of the CFS apps in there. We're not using anything like CFDP because that would just eat up all of our memory right now.